Hello, everyone. In Trigonometry 001, we introduced the idea of what an angle was based on two rays with a common vertex. And then I argued for the existence of 6 different ratios to account for the 6 different trig functions: sine, cosine, tangent, cotangent, secant, and cosecant. And from that, I was able to introduce a couple other triangles, special triangles, the 1, 1, 2 square root of 2 triangle, and the 1 square root of 3 2 triangle, 1 square root of 3 2 triangle, which is the 30, 60, 90, or the pi over 6, pi over 390, or pi over 490 triangle, as well as the pi over 4, pi over 4 90, or pi over 2 triangle. So we had these various triangles. We can use that to do the special angles, and then I created the unit circle. So that was what Trigonometry 003 was about, which was the trigonometry of special angles. And we were able to develop this nice unit circle. Now we got to remember that as long as you use that y is the sine of theta, and that cosine is, or x is the cosine of theta for the unit circle, you can then make a graph of sine theta and cosine theta and even tangent theta. So I want to start off right now by using our unit circle. I'll show you that again in a second. And then I'll use that unit circle to create a graph of sine theta. In the next video, I'll show you a graph of a cosine theta. In the next video, I'll show you the graph of a tangent theta. So let me turn to my unit circle that we completed in Trigonometry 003. So this was it, and I worked it out by using these little triangles and realizing the hypotenuse, which is the radius in each case, is just 1, and using the fact that sine of theta, because this is 1, is ultimately just y, and cosine of theta, since again this is just 1, is actually x. So I was able to work out these exact values at these points. So now I'm going to make a table of basically what we normally call x and y, but instead I'm going to call y and theta, and I'm going to make a table of those so we can graph them. So we're just relying on our use of that. I definitely recommend you make your own unit circle. I'd suggest you make it maybe 2 or 3 times, and then you won't be so much memorizing it as it's just stuck in your head without intentionally memorizing. It's just memorizing because you really had no other choice, because you've done so much repetition with it. And that is really the secret. At the end of the day, mathematics, physical sciences, probably other fields too, but they're not my field of expertise. Repetition is your best friend. It's the sole way to learn things that you need to know. So let's make a table. I'm going to make a table. First, I'm going to do theta in radians. And then I'm going to do theta in degrees. Okay. And then I'm going to do y equals sine theta using our special angles. So the very first angle I'm going to attack is 0 degrees, which is also 0 radians. And we know, since y is equal to the sine of theta, then when I take the angle of 0 degrees, I know that the y value at that point is 0. So I know sine of theta is 0. Now take the next angle, which is going to be pi over 6. And of course, pi over 6 radians is exactly equal to 30 degrees. And again, looking at my unit circle, I know that the y value for pi over 6 is 1/2. So it's going to jump up to 1/2. My next one is pi over 4, which we also know as 45 degrees. And then again, the y value is the sine, so that's root 2 over 2. The next value is pi over 3, which is twice pi over 6, and therefore is 60 degrees. Again, the y value is the sine, so I'm going to say root 3 over 2. Now I'm going to go to pi over 2, which is 90 degrees. And of course, at 90 degrees, the point is 0, 1. So we know that the sine of theta is 1, because again, sine theta is the y value. And now I can continue on and go to 2 pi over 3, which of course is 120 degrees. And of course, the y value is root 3 over 2. But I think you can see from the symmetry of it, it should be root 3 over 2, followed by root 2 over 2, followed by 1/2, followed by 0. And that's what we're going to see. So the next value is 3 pi over 4, which of course is 135 degrees. And then again, the y value is root 2 over 2. And then the next value is 5 pi over 6, which of course is 150 degrees. I'm going to try to stop writing it on that red line so y'all can see it a little better. Looks actually like you're doing pretty well. The y value of that is 1/2, so sine of theta is 1/2. Now we can go to 180 degrees, which is of course pi. So it's pi, which is 180 degrees, and pi is 180 degrees, gives us a y value of 0, so sine is of course 0. And that's exactly what we expected. Notice the symmetry. Root 3 over 2, root 3 over 2. Root 2 over 2, down 2, root 2 over 2. Up 3, 1/2, down 3, 1/2. Up 4, 0, down 4, 0. So now we can jump to the next value, which is 7 pi over 6. And of course, 7 pi over 6 is 210 degrees. And the y value there is negative 1/2. So notice the negative 1/2, the 1/2 value is always next to the 0. So this time we switch to a negative. So we're going to have probably another symmetry just like we did before. The next value is 5 pi over 4, which is 225 degrees. And of course, the y value for 225 degrees is negative root 2 over 2. So I'm going to say negative root 2 over 2. Notice that is 2 away from 0, and we got it 2 away from 0. 3 away from 0, of course, should be root 3 over 2. So we're expecting this to be negative root 3 over 2. And lo and behold, when we do 4 pi over 3, which is equal to 240 degrees, we get y value being negative square root of 3 over 2, which is exactly what we expected. And then, of course, if we go to 3 pi over 2, which is 1.5 pi, that's also 270 degrees, we see that the y value is negative 1. So some really nice symmetry here. You can expect, since the 1 was there, you'd expect to be root 3 over 2, root 2 over 2, 1/2, and then 0 again. But of course, we're down on the negative side, so we expect all that to be negatives. So first off, I'll try 5 pi over 3. And 5 pi over 3 is, of course, 300 degrees. And the y value for that is negative root 3 over 2, which is exactly what we expected. And then the next value is 7 pi over 4. And 7 pi over 4 is 315 degrees. And the y value there is negative root 2 over 2. Again, that's what to be expected because it's 2 away from the 1. And then we have 11 pi over 6. I've now written outside of the writing zone of the screen, so I'm going to pull it back up a little higher. So now we have 11 pi over 6. At 11 pi over 6, that angle is in fact 330 degrees. And at 330 degrees, we see that the y value is negative 1/2. So as expected, the third away from the 1 should be a value of 1/2, but in this case, it happens to be a negative. And then finally, we're back to 2 pi radians, which is 360 degrees. And of course, we know at 360 degrees, which is the same as 0 degrees, the y is equal to 0. So the sine is equal to 0. So we now have the sine values for the various angles. So now let me stop and share my screen for a second. I'm going to share this screen right here. And I'm going to use Desmos to plot those points. Now, it'd be better to just do it in graph paper, and I'd highly recommend you do that. But right now, I'm just going to do it for a quickness, and we can actually graph these points. So I'm going to go to the graphing calculator. And when you're in this, you can actually set up things as you wish. So you can, for instance, click on this graph setting, and you can make sure, for instance, that we're on radians, and we are. And now we have everything set. Actually, I could change the Y values and X values as well, but I'm going to start off with the first data point from our numbers, which is 0, 0. So I've got that. The next point was pi over 6, 1/2. So I'm going to say, pull up my special little calculator, which allows me to find special things. And my screen is actually hiding some of the keys. So I'm going to say, nope, it did not let me do that. Let me make the screen a little pi over 6. Now I'm going to copy that so I can use it over and over again. Put parentheses around it, pi over 6, comma, 1/2. Again, that was the second line, so now we got that point. Now I can do pi over 4, comma, whoa. Now go down 4, comma, whoa, we don't want that either. Got to watch what you're doing with this thing. So now I hit comma in there. In this case, it's root 2 over 2. So I'm going to say square root 2, get outside the square root, divided by 2. Close parenthesis, get it there. And now I've got my third point. And now my fourth point would be pi over 3, parenthesis, control V, that's pi, divide that by 3. And again, it's root 3 over 2. So I got to get outside of that, hit comma, and do square root 3, get outside of the parenthesis, divide it by 2. And close parenthesis, whoa, not like that, got to get outside. Close parenthesis, I got that. And then I'm going to go to pi over 2. So parenthesis, whoa, parenthesis, control V over 2. And I don't know why I hit divide there. Put a comma in, and for pi over 2, we got 1. So 1 is the Y value. And I don't know where that J came from, fat fingers, I suppose. So that's the first quarter of our pi graph, or excuse me, of our sine graph. You can see it starts to, it shoots up sort of looking like it's linear, but then it starts to curve over. It's not really linear at any point, but as small a point as you want, you can get it pretty close to linear. So now I'll continue with 2 pi over 3, 2, control V over 3, comma, and that's root 3 over 2, square root 3 divided by 2, close parenthesis, nope, close parenthesis. Now we got that. Now we got 3 pi over 4, parenthesis 3, control V over 4, step outside, comma, so root 2 over 2, square root 2, step outside, divided by 2, in parenthesis, no, step outside first, and then in parenthesis. And you start to see the graph really coming together now. It's actually going to make a nice little wave. As you can see, just by graphing this, the wave will continue. It goes from 0 to 1. That 1, of course, occurring at pi over 2. And these units really should be in units of pi. It'll make life a lot easier. Then it'll continue down to 0, which it'll reach at pi. Then it'll continue down to -1, which it will reach at 3 pi over 2. And then it'll continue up to 0 again, which it'll reach at 2 pi. So you can see that already. Let's do this. Let's change our axis from negative, let's say from negative, whoa, why does it keep it in that? Okay, -4 pi to 4 pi. And I want the steps to be in units of pi over 6. Now when I do that, I can look back at this graph. As I close this window. And now you can see it looks a little more reasonable. You can actually see the points coming up. You can see that it's starting to converge on this. Let me do a couple more points so you can see that indeed we're going to get what we expect. So the last one we did was 3 pi over 4. I'm going to do 5 pi over 6. So parenthesis 5, control V over 6, step outside, comma, and then of course that one's going to be 1/2, close, step outside, close parenthesis. And then now we can finally get at the value pi, control V, comma, 0. Now you can see the graph is as advertised. Now what I'm going to do is, now that you've seen these points, I'm just going to say y equals sine of x. And you see that is indeed a graph. Now all we did was 0 to 2 pi, and I didn't do anything in terms of, I'll straighten that back down to 2 pi. And I didn't do anything in terms of negatives, but that's actually really trivial. If you look on your unit circle, all the angles we did were going in the counterclockwise direction from the positive x-axis. If you go in the clockwise direction from the positive x-axis, you're getting the actual negative values. So for instance, the 11 pi over 6 is equivalent to negative pi over 6. And you'll see that negative pi over 6, of course, gives a sign of negative 1/2. So that would be negative 1/2 right there. And that's how you get the negative side. And of course, if you go all the way around the unit circle, you get to 2 pi. Then you go to 2 pi plus pi over 6. And that's just basically the same thing as pi over 6. And if you go to 2 pi plus pi over 4, that's just the same thing as pi over 4. And if you go to 2 pi plus pi over 3, then that's the same thing as pi over 3. So it just repeats itself, and it repeats itself the same way backwards and forwards. So we now have a really good graph of sine x, as you can see from the points. So let me show you that again on the unit circle, exactly how we go about getting these. So we did all these, but if you wanted the negative angles, you'd say, okay, I'm going to go, this was all the positive direction, counterclockwise from the positive x-axis. That's the positive direction. Once you get to 2 pi, it just repeats itself. So you can say, okay, well, when I get to 2 pi, if I add pi over 6 to that, 2 pi would be 12 pi over 6 plus 1 pi over 6. That's 13 pi over 6. So 13 pi over 6 has a y value of 1/2. And that's just basically 1/2 higher than the 0 that we had gotten. But if we want to do the negatives, we just go this way. So this is basically negative pi over 6. And of course, negative pi over 6 has a y value of negative 1/2. So that's how we get that the sine of negative pi over 6 is equal to negative 1/2. If I want a negative pi over 4, I go down this far and I say, oh, okay, well, that gives me negative root 2 over 2. So that gives me the negative value. If I go to negative pi over 3, I see that the y value is negative square root of 3 over 2. So that's my graph point for negative pi over 3. And then again, if I go negative pi over 2, I get my y value is negative 1. And just like the graph showed, in fact, it just repeated itself backwards in time as a negative loop. So in general, the graph of sine is just a wave from 0 to 2 pi that goes like that. If you go to negative pi, it's just this to this. So if I go from 0, negative pi, negative 3 pi over 2 pi, it goes like that. And of course, it just continues to repeat itself as we showed on the graph. So that's easy enough. We have now learned how to graph the sine of theta on a regular graph. We see the units. That's nice to work in. It's better to work in units of pi, or specifically pi over 6 units would be even better. So let me look back at that screen one more time so you'll have this graph fixed in your head, because this is a graph that you can use over and over in physics and math and chemistry, all sorts of cool stuff. So notice it's just, this is the shape of the sine graph. It goes up to a peak, goes back down to 0, goes down to a negative peak of -1, and then back up to 0. And that's sort of what we call one wavelength. That's the smallest area over which it starts to repeat itself. Once I get beyond 2 pi, notice it just exactly repeats what's happening to the left, to the right of 0. So this is exactly the same thing as this part right here. And what we saw from going to negatives is basically we're just doing the angle in a counterclockwise or in a clockwise direction, and we get exactly the same graph, but it's flipped over. That's something that has something to do with what we'll call parity and that sort of thing. And you can see in this case, if you know about parity and oddness and evenness and all that good stuff, you would say that the y equals sine x is an odd function, because when you replace x with negative x, you get the negative of the sine of x. So sine of pi over 2 is 1. The sine of negative pi over 2 is negative sine of pi over 2, which is -1. So on and so forth. So you say the sine of pi is clearly 0, but the sine of negative pi must be negative sine of 0, which is just 0 again. And if you say the sine of 3 pi over 2 is -1, then the sine of -3 pi over 2 is negative of the sine of 3 pi over 2. And of course, the sine of 3 pi over 2 is -1, so the negative of that is +1. I hope that helps you understand where the graph of sine comes from. Next, we'll do the graph of cosine.